This is section 7.5, Theorems for Similar Triangles. So far, we've come up with two ways to prove that two triangles are similar. We could do it by the definition of similar polygons, which means in our two triangles we've got to show that all three pairs of corresponding angles are congruent and all three pairs of corresponding sides have the same ratio. So that is not very friendly. Ugh. 6 things we'd have to show if we're going to use the definition to show that two triangles are similar. Not very user-friendly in a practical sense. But we also have, from section 7.4, the angle-angle similarity theorem, which says we don't have to show 6 things as long as we can just show that two pairs of corresponding angles are congruent. Well, very nice. 2 things. That's all I have to show. That's great. But what if we only know about one pair of corresponding angles? What if we don't know that two pairs are congruent? What if we only know that one pair is congruent? How much information about the sides would be sufficient for us to know that the two triangles are indeed similar? Do we need to know all 3 pairs of sides are congruent? And what if we don't know any pairs of angles at all? We're not given that any of the angles are congruent. Can we still find a way to deduce that we have similar triangles? Turns out we can for both of these. First, if we know one pair of angles is congruent, we don't need to know all 3 pairs of sides have the same ratio. We have the side-angle-side similarity theorem that says if an angle of one triangle is congruent to an angle of another triangle, so we've got one pair of congruent angles, and the sides including those angles are in proportion, then the triangles are similar. So we actually only need to show 2 pairs of sides are in proportion, if those pairs of sides are the ones that contain the angles we have. So, for example, if we're given that angle A is congruent to angle D, and we know AB over DE equals AC over DF, then we know the two sides that contain our angles are in proportion. So we know, we can say then triangle ABC is similar to triangle DEF by the side-angle-side similarity theorem. If the sides we were given were not the ones that contain the angle, like if we were given AB over DE equals BC over EF, then we would not know that the triangles are similar. This only works if the 2 pairs of sides we have are the ones that contain the angles we have. Okay, now my second question. What if we don't know any pairs of angles at all? Can we still deduce similar triangles? Turns out we can, under the side-side-side similarity theorem. If the sides of 2 triangles are in proportion, then the triangles are similar. So if all 3 pairs of sides have the same ratio, then the 2 triangles are similar. So if we're given that AB over DE equals AC over DF, which equals BC over EF, all 3 pairs of corresponding sides have the same fraction, the same ratio, then they are all in proportion. So this theorem tells us then triangle ABC is similar to triangle DEF by the side-side-side similarity theorem. So now we've doubled our ways of showing that 2 triangles are similar. We've got the definition, not very good. The angle-angle similarity theorem, very nice if we know 2 pairs of angles. The side-angle-side similarity theorem, if we only know one pair of angles and we know 2 pairs of sides that contain those angles. And the side-side-side similarity theorem, if we don't know any angles at all are congruent, but we know that all 3 pairs of sides are in proportion. So here's some examples. Can the information given in each problem be used to prove that triangle RST is similar to triangle WZT? If so, how? What of those 4 ways are we using? So number 1, if RS equals 18, ST equals 15, RT equals 10, WT equals 6, ZT equals 9, and WZ equals 10.8. So we don't know any angles, but are all of our sides in proportion? Okay, so that's try to set up the corresponding sides and see if they are in proportion. Okay, now it looks like SR is definitely the longest side of its triangle, so it's going to have to correspond to the longest side of the other triangle, which is ZW. If these are going to be similar, the longest side is going to have to correspond with the longest side. So let's try 10.8 divided by 18. And 10.8 divided by 18 is, if we were to use a calculator, we can get it really quick, 3 over 5. Okay, it's 3/5. So we need to get the same fraction when we try the other pairs of corresponding sides. So those were the longest sides. Let's try the middle pair of sides. ST, which is 15, and ZT, which is 9. So we're going to have 9 over 15. If we reduce 9 over 15, we know 3 goes into both 9 and 15, and we get 3 over 5. Good. We need to still check one more pair. Now we try the shortest sides. That's TW, which is 6, over RT, which is 10. And we reduce 6 over 10. 2 goes into both of them, and we get 3 over 5. Yes, all three of them are the same. So, yes, triangle RST is similar to triangle WZT by side, side, side similarity theorem. Okay, same picture, but now we're given different information. If we know angle 1 is congruent to angle 2, and WZ over RS equals TZ over TS. So we've got a pair of angles, so we're going to look to try to use side angle side. WZ over RS and TZ over TS. That's a problem, because the sides we were given, the TZ and TS, are not the sides that contain our angles. So we don't have the sides that contain our angles. So we have to say, no, we don't know, because we don't have the sides that contain our angles. We've got one of those pairs of sides, but we don't have the other one. So we can't say that these triangles are similar by side angle side. But what about number 3? If we know ST is perpendicular to RW, so we've got some right angles down here, and ST equals 32, SZ equals 8, RT equals 20, and WT equals 15. Okay? Notice they gave us ST and they gave us SZ. We can use that to figure out ZT. ZT is ST minus SZ, so it's 32 minus 8. ZT equals 32 minus 8. 32 minus 8 is 24. So ZT is 24. Okay. So we've got a pair of angles because of those perpendicular lines give us congruent right angles. We've got a pair of angles, and we are actually given information about the sides that contain those angles. So we just have to check and see if those sides are in proportion. So let's take RT, which is 20, and put that over WT, which is 15. Okay, 20 over 15. We simplify that. 5 goes into both of them. We get 4 over 3. Now we need to check the other pair of corresponding sides. So that's going to be ST, which is 32, over ZT, which is 24. And 32 over 24, we reduce it. 8 goes into both of them. 4 over 3. Look, they're the same. Yay! And yes, triangle RST is similar to triangle WZT by, what do we use? Side angle side similarity theorem. Okay. Similarly, you want to do these two immediate practice problems. You want to make sure you draw the pictures and Write the problems. Okay. Same picture for both problems. Number 1, in triangle ABC, AB equals 4, BC equals 5, and AC equals 7. In triangle XYZ, XY equals 16, YZ equals 20, and XZ equals 28. Are the two triangles similar? Why or why not? If they are, you're going to tell me if it's side, angle, side, 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 or angle, angle similarity, or the definition. If they're not, you're going to explain why we don't have enough information. And number 2, if angle A is congruent to angle X, and AB equals 2, AC equals 5, and XY equals 6, and XZ equals 12. Are the two triangles similar? Why or why not? And that is the end of section 7.5.